Welcome to our presentation on VeRdict, a multilingual dictionary extension for VR applications. My name is Noel Vincent, and I'll be your presenter today. My co-author is Louis Lecaillie. As most of you watching will surely know, VR has become quite popular within the past 5 years. In 2015, there were hardly any VR users on the Steam gaming platform, whereas now there are up to 18,000 monthly active users playing games on the platform. Another interesting statistic is that now 1 in 50 Steam users owns a VR device. There are already a number of interesting VR applications for language learning that are available commercially now. Though not strictly speaking VR, since it does not make use of a VR headset, a game known as Influent allowed users to walk around a virtual house, click on objects, and see the name of those objects in a foreign language. This is related to the concept of a memory palace. Another example is Mondly VR, where users interact with a virtual agent to practice their conversational ability in a second language. Going beyond single-player games and applications, there are also social VR learning experiences. Though not strictly speaking made for educational purposes, a platform known as VRChat allows users to get on the platform, upload their own content, and then interact with other users in a spontaneous fashion depending on their own personal interests. This platform is great for language learning because it allows people to communicate through voice and body gestures. However, there are some challenges associated with language learning in VR. One is that conventional resources such as dictionaries and textbooks are not available inside of the VR application. To access these resources, some form of app switching may be necessary. If standalone dictionaries for VR are not available on the given platform, a user may have to remove his or her helmet in order to pick up a conventional dictionary or a mobile dictionary, search for the word that they were not able to understand, and then put their helmet back on. This causes a great distraction and may interrupt learning activities. A possible solution would be to incorporate a VR dictionary directly into the VR learning applications. This would have the benefit of helping users maintain focus. They would avoid the attentional or social penalty of switching between different contexts. Additionally, they would be able to view virtual 3D objects alongside a text definition to help them better understand a word or concept. Additionally, virtual objects can be used as learning aids or learning props to help explain concepts for which there is typically no visual representation. Examples would include verbs or prepositions. Some examples will be given later. Currently, we imagine 3 primary use cases for this technology. One is searching for words by object labels. So in this instance, a picture of an owl could be selected, its label would be displayed, and then this word could be searched from the label. Additionally, users could manually search for a word by typing it into a virtual keyboard. This is useful in scenarios when users are talking to other users on a platform and simply do not know which word to use. Additionally, users could combine 2 virtual objects to explain some other word or concept, such as night in this case. Okay, now let's see how this technology works in action. First, a user will notice a hamburger button hovering in their line of sight. When they click on this, it will open a menu. From this menu, you can see that there's a search bar and a multilingual keyboard that can enter characters in Latin or Japanese kana in this instance. Other languages can be added as necessary. In this case, let's search for the word frog. When the search button is clicked, a definition of the word will appear, which features the Japanese kanji, its phonetic equivalent, the English equivalent, and several example sentences. Additionally, a 3D model is instantiated. It can be picked up and manipulated by the user. The user can then set it down anywhere within the scene. Now let's search for another term, this time using the Japanese keyboard. Let's search for the Japanese word for dog, inu. When we click search, you'll see that a similar definition page pops up, even though we've searched in Japanese kana. As well, you can see that another 3D model has been instantiated, this time a dog. Let's place it next to the frog. I think he could use a friend. Now, let's talk about the second use case, which is searching for entries from object labels. Let's say, for example, I don't know how to say computer in Japanese. I can walk over to this computer, which has an associated object label, click, and then I'll see a label that pops up with computer. In this case, it's written in Latin characters. But if I use the search button, once again, it will take me to the dictionary menu where I can see the Japanese equivalent is pasokon. Here again, I can see the English equivalent and several example sentences. Here you can see that many objects within the same scene can have object labels associated with them. As much as I like the dog and frog, they're cluttering up my desk, and I need some more space. Let's get rid of these instantiated objects by placing them in the trash. The specific method for removing objects may vary from application to application, but in this case, we've created an animation that is triggered when the object is placed in a trash can. Now that I've cleared off my desk, let me demonstrate the third use for this technology. Let's say that I want to explain an action word, such as where, and my friend is not very proficient at English. By looking up the definition for where, all I would receive is text, which might not be very useful for explaining this concept to my friend. But I can explain it by proxy. First, I'll search for the word hat, and when I click the search button, it will instantiate a 3D object of a hat. I can pick this up, and if I were speaking to my friend, I could demonstrate the action of wearing a hat. Wear. Wear. In this way, I can explain something that does not have an associated 3D object. As a future step, we'd like to conduct a pilot study to see how this technology is actually used in the wild, so to speak, by real users who are learning a foreign language. By gathering thoughts from users about what features were useful and what were not, we could improve the usability of this technology and potentially add other useful features. Upon concluding the pilot study, we'd like to investigate the effectiveness of this technology in a controlled experimental setting. We think that this would be of great benefit to language learners, especially those who are just beginning and may not know exactly how to interpret a text definition found within a dictionary, but may, through the use of visual aids, be able to understand more than they would otherwise. Thank you so much for watching our presentation. If you'd like to contact us, please don't hesitate. I've been your presenter, Noel Vincent, and you can find my email here. Additionally, if you're interested in information about other VR projects that I'm currently working on, please visit moji.media or scan this QR code here. Once again, thank you very much.